Welcome to the session on trigonometric functions, trigonometric identities. The objectives for this session are to prove and use cosec²x is identical to 1 plus cot²x and sec²x is identical to 1 plus cot²x. Let's begin by recalling the reciprocal trigonometric functions. Sec equals 1 over cos, cosec equals 1 over sine, and cot equals 1 over tan. Remember that also we have that tan equals sine over cos implies that cot equals cos over sine. We can also use the identity sin² plus cos² is identical to 1 to prove other identities. We're going to do this in the first example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's consider part A first. We are required to prove that 1 plus tan²x is identical to sec²x. So let's solve this. We begin by dividing sin²x plus cos²x is identical to 1 by cos²x. This gives us tan²x, since tan x equals sin x over cos x, plus 1, since cos² divided by cos² is 1, is identical to sec²x, since sec x equals 1 over cos x. And therefore we've proved the result. Now let's solve part B. We are required to prove that 1 plus cot²x is identical to cosec²x. So let's solve this. We're going to begin by dividing sin² plus cos² is identical to 1 by sin². As shown. Tidying up gives us 1, which is from, of course, sin² divided by sin², plus cot²x, since cot x equals cos x over sin x, is identical to cosec²x, since cosec equals 1 over sine. And therefore we've proved the identity. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first. Given that tan A equals minus 8 over 15 and the angle A is a reflex angle, find the exact value of cosec A. So let's solve this. We're going to begin by using the identity 1 plus cot²x is identical to cosec²x to give us 1 plus cot²A equals cosec²A. Since tan A equals minus 8 over 15, we have that cot A equals minus 15 over 8. And so if we plug this into our equation, as shown, we have that 1 plus minus 15 over 8 all squared is equal to cosec²A. And therefore, cosec²A equals 1 plus 225 over 64, which equals 289 over 64. And so square rooting this gives us that cosec A equals plus or minus 17 over 8. In the cast diagram, we're only interested in the quadrants in which tan is negative, since tan A equals minus 8 over 15. and tan is negative in the second and fourth quadrants, where only sine is positive and only cos is positive. However, we're only interested in reflex angles, since that's what's stated in the exercise or the example, and therefore we're only actually interested in the fourth quadrant. And here we have that cosec equals minus 17/8, since in the fourth quadrant sine is negative, and therefore, of course, 1/sine is negative also. And now for part B. Given that tan A equals minus 8/15 and the angle A is a reflex angle, find the exact value of cos A. So let's solve this. From part A, we have that cosec A equals minus 17/8. And of course, this implies that sine A equals minus 8/17. But since tan equals sine over cos, we can plug in all the values that we have in order to find the value of cos. So here we've plugged in the value of tan A, here's the value of sine A, and cos A is what we need to find. And rearranging this gives us that cos A equals 15/17. And now for the next example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at part A first. We are required to prove the identity sec⁴ minus tan⁴ is identical to sec² plus tan². So let's prove this. Since the left-hand side is the difference of two squares, let's begin with the left-hand side first and factorize it. As shown. Notice that sec² in this expression is equal to 1 plus tan², so we substitute that. And so we have this expression here. And then tidying up gives us 1 times sec² plus tan², which is of course identical to sec² plus tan², which is identical to the right-hand side of the identity we're trying to prove. And now for part B. We are required to prove the identity 1 minus tan² all over 1 plus tan² is identical to 1 minus 2 sine². So let's prove this. We're going to begin with the left-hand side and start to simplify it. Notice that 1 plus tan² is identical to sec², so we replace that as shown. And then we split the fractions to give 1 over sec² minus tan² over sec². Since sec equals 1 over cos, we have that 1 over sec² is equal to cos², as shown. Tan can be re-expressed as sine over cos to give tan² is identical to sine² over cos². And 1 over sec squared is equal to cos squared, since sec equals 1 over cos. And now we can tidy up. The cos squareds cancel, as shown, to leave us with sin squared. And so we have cos squared minus sin squared. And keeping an eye on what we're trying to prove, let's now replace cos squared with 1 minus sin squared. To give us 1 minus 2 sin squared theta, which is identical to the right-hand side of the expression we were trying to prove. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We are required to solve the equation 13 sin theta equals 1 plus 5 cos squared theta in the interval 0 degrees less than or equal to theta less than or equal to 360 degrees. We can rewrite this equation as 1 plus 5 cos squared theta minus 13 sin theta equals 0. We're going to replace cos squared by 1 minus sin squared so that we have a quadratic in sine, and then we can solve for sine. And then tidying up this expression gives us this quadratic. And we can factorize this as shown. This implies that either sin theta equals 2 over 5 or sin theta equals minus 3, which is clearly impossible. And therefore we have that sin theta equals 2 over 5. If we plug this value into the calculator, we obtain that theta equals 23.6 degrees. Now, there is another solution here. We need to look at all the quadrants where sin theta is positive. So this occurs in either the first quadrant, where we already are, or in the second quadrant. And this also makes an angle 23.6 degrees with the x-axis. But the angle itself is equal to 180 degrees minus 23.6 degrees, which is equal to 156.4 degrees. And so we have the two solutions, theta equals 23.6 degrees or theta equals 156.4 degrees. This brings us to the end of this session. If you have understood its contents, you should be able to prove and use the identity cosec²x is identical to 1 plus cot²x and sec²x is identical to 1 plus cot²x. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.